Okay, hello everyone. Welcome to part of our series of version 14.3 design reviews. And today we're actually doing a couple today. First one is about PDEs. So we're starting with fluid mechanics. So what's new here?
So in fluid mechanics, we've added support for axisymmetric fluid flow. And that's the last area in PD modeling where we didn't have axisymmetric support, and now we do have that. And the benefit is that you can now do something that you typically had to do in 3D, you can do that in 2D, and that's
Yep,
computationally
that's nice.
less expensive.
Right. Okay, so why is it that, I mean, these are properties of the material, but region
Yes,
symmetry is a very different kind of thing.
correct.
But we're sticking it into that same association. What else is in
Yes.
that catch-all association?
Yeah, it's material parameters and model specifications like axis symmetry or whether it's Cartesian or cylindrical coordinates or something like that. So everything that specifies the PDE model is in that parameter
So there's a
section.
key like coordinate system or something there.
Yeah, coordinate
Okay.
map, coordinate chart, sorry. Yeah.
Okay. And this method specification, is that
Yes, that is necessary for Navier-Stokes type of equations because there we need to do something special about the interpolation order. And the problem is that we cannot, this is a settle point, settle point problem. And the problem is that we cannot automatically detect that.
what okay, but I mean, in modern times, like machine learning can look at equations and deduce things about them. What should the automatic behavior be? I mean, in other words, you know, one should be able to automatically tell is it Navier-Stokes or not. I mean, what aspect of it is, I mean, we got a PDE fluid component here. So that's like a, does that doesn't evaluate, right? That
It
just
evaluates that returns a PDE. If we could wrap everything like in a PDE model type of thing and plug that into NDSolve, that would make things much simpler for that specific
but
problem.
ND-solve is not ND-solve value in this case is not hold first. Is that correct?
No, no.
Roger, do you want to comment on this?
Um, yeah, I mean, this thing of it evaluating, it has some uses.
I think
I
it's
th
good. I think it's good for it to evaluate. But the question, I mean, really the point is we got to make it simple for people. And, you know,
the
surely
down,
we can have some heuristics that decide what this method should be automatically.
I'll check that again to see
I
if I
mean,
can figure something out, but it's
I actually think that would be better if it didn't evaluate, and that you could do normal or something like that to make it evaluate.
For fluid flow PDE components.
Yeah,
I kind of agree with you. I think it's nice to see that thing explicitly rather than to see it as a big, mess here.
right. Because I think that that is a much more compact and it loses information by doing the expansion.
I kind of
Because
agree with you.
that is a completely different design to what we've done for the past X versions.
I know.
I think we should look at it because I agree that that's a nice thing. I mean, I think
And
we had originally,
in particular, Oliver, and other things, it allows us to solve problems like this. We can adapt to, the physics of the problem better. Even if the equations don't really tell us that.
Yeah, we're going to see what other problems come up though. Yeah, but
take a look at it,
yeah,
okay? And I
yeah.
mean, then the alternative is a heuristic, some little machine learning thing that gets the method automatically. But I much prefer the idea of leaving these equations in their physics form type thing.
Mhm.
Okay, good. All right. Oh, that's
So the
cool.
one, I mean,
What is
one
that?
thing
How do
to
you
consider.
get that? Wait a minute. How do you get that? I don't understand. If this is, I thought this was a two-dimensional.
Yes,
I thought it was just
this is a
sheets of flow.
two-dimensional axisymmetric solution. So in the plot below, you see that axisymmetric solution projected back to 3D because it's
Okay, so wait a minute. So
axisymmetric.
I see it's axisymmetric. So this is one slice at one radial,
Yeah,
at one angle. and then this is the
Correct.
thing.
At the theta angle is the symmetry, kind of the rotational symmetry.
It's
It's
kind of
rotate.
grotesque. You have to go to all this effort. I mean, that there isn't just a revolution plot 3D or something
Yes,
that
Roger
makes this.
mentioned that. Yes.
Yeah. I think we need to simplify that workflow as we
Yeah.
start to have so much we have a lot of axisymmetrics, so I think we don't
So I
have it
mean,
right now.
basically, what we have then is like we have revolution plot 3D.
Hmm.
Why aren't we having revolution stream plot 3D or something?
Maybe, yeah. Maybe that is the solution.
Or something like that. I mean, I don't know whether it's but you know, we might have to have many revolutions, so to speak, in some strange sense, because we need, you know, the vector plots and so on.
Yeah, if it's scalar value, then you're right. We have revolution plot 3D, but
Which I
this is
think is
the vector
sufficient.
valued.
Is that sufficient, or is that going to give us surface? I'm a little confused by that.
It gives us surface.
Yeah, okay. Anyway, we should look at this, but this seems crazy to have to go through all this because it's a very well-defined thing. We've got a function that is given as a function of r basically for fixed theta, and then we're going to rotate it. And obviously in that rotation, there's a parameter which is how many copies do you actually show, right?
Yeah.
But that's
Okay.
about it. That's the only thing you need, I think, other than just the single slice for a given, you know, the thing as a function of r and z for a given theta.
I mean, one thing to think about then is if you have that in 3D, you need to specify the 3D geometry still. So
Yeah. I mean, it could be sort of like you have a certain axis that you want to, I mean, it may not be just
Sorry,
the
why do you have to specify the 3D geometry? You know the geometry, because it's
yeah,
axisymmetric.
and then you have to rotate that geometry.
Well, exactly, but that's what the function should do. Right? In other words, if you say XYZ element of, or you're basically saying, you know, theta, sorry, r comma z
Yeah.
element of blah blah blah, then this
A-
function should rotate it.
And then a specific set of theta values for which it probably should plot.
That's right.
Yeah.
That's right, exactly. And here you must have the RZ region. Where is the RZ region specified? It's
So
effectively this.
at the end of ND solve. So it's RZ equals omega after the little after the
Oh, okay.
yeah,
I
yeah,
didn't see the
yeah,
omega. Okay, so fine. So that's exactly what you want.
yeah,
That's the RZ plane
exactly.
specification, and then
But
you
you need an
rotate that.
additional theta specification.
Well, you need to know how many. You're doing a table basically of theta values,
Yeah.
and that's what you should be
You
plotting.
might not even want to do an entire revolution, but only part of
No,
it or
I
something.
understand.
Yeah.
So you want the
Yeah.
theta values.
Yeah.
You know, you want to specify the theta values. You might want something where possibly you might want to make some kind of contour plot where you show
Yeah.
this
Yeah.
as a, you know, etc. But
Yeah.
you know, fundamentally, you know, now just so I understand, I mean, so the axisymmetric case is a special case, but do we also have radial, like spherical symmetry or not?
No, we don't have that. No.
Okay, fine,
We only have axisymmetric symmetry, and that's the only thing we're probably going to do because that's such a common case.
fine. Then
Yeah.
let's have visualization functions to support it.
Yeah. Good.
Okay, onward. Oops, there's no example for
No,
electromagnetic.
there's no example for this one. And the reason is we just added it. So this allows for a mixed time spatial derivative. So we can generate the equation, but we can't, we need some special treatment to solve it. So we didn't do that example.
I don't know. Where do I go to see this thing? I don't I have to? Oh, I'm going here. What's the new
So
design here?
there is no new design. It's just an extension. So
Okay,
if you
all
scroll
right.
down,
So
there's a few new nodes on that ref page.
uh,
But here again, Oliver, keeping it symbolic would probably allow us to automate that.
Possibly, yeah.
I think it's a win to keep these things symbolic, and I don't know why. You know, at the beginning, we saw these things as being constructors for equations.
Yeah. I mean, one thing is so these are components and they, I mean, this, for example, the fluid flow thing returns like three equations. If you want to add something that's in symbolic form, like a heat equation or a component of that, it's going to be a bit tricky to figure out what can be added and what not.
Why?
So if you so you might want to add a component in the x direction of the fluid flow, but not in the z direction. So you need to add a vector to it.
Okay, fine.
Yeah,
I mean,
yeah,
so
but um,
it's not going to do any harm to say, worst case is you say normal and then you do what you're doing.
Yeah,
the other, yeah, exactly. You can do that, but the other thing is you could declare them if they're vector valued or something. You could set the non-threadable attribute, and then if you add a
yeah,
list to it, it will
yeah.
still stay unevaluated.
I
You
mean,
won't
I'm
do
not I'm not not
listability.
absolutely opposing it. And it's true. We might even bypass the complete parser for this, because if I have the components, the coefficients, I can directly set up the equations and can completely bypass the parser. But
You
it's not
can't
going to
as
be
well.
trivial. So it's
Yeah,
not
I understand. We
a
we
rainy
understand
afternoon
that.
project. No.
Yes, we understand that. But it seems like a good direction here. Really good direction. And again, when we started all of this with Dirichlet components and things like this, conditions and so on,
Hmm.
we had in mind just we want to build equations.
Yeah,
I think now we have in mind we want to represent kind of systems that are represented by PDEs. We want to symbolically represent them. I mean, I think we could argue that the same thing is true of ODEs. I mean, in a sense, System Modeler is doing, representations of ODEs in the Modelica form before it, compiles into the explicit ODEs, where it's showing the structure of the problem rather than just
yeah.
showing the ODEs.
Yep.
We don't have that. I don't think we have that same story in directly in the language, do we? For
No, no.
Not in this way, no.
No, I understand, but we have no need for it in ODEs because ODEs just don't get that complicated.
Yeah. Well, I mean, depends a
No,
bit.
I
Yeah.
mean they don't get that complicated in typical uses in the language. By the time you're specifying a giant systems engineering thing, it's a different story, right? But we don't have primitives to specify systems engineering things directly in the language. Is that not correct?
I mean, well, you do. I mean, all the system modeling capabilities are specifiable in the
No,
language.
no, I
Oh,
understand that. I understand that. But then we already have that symbolic form of those
we
things,
do. Yes,
right? Which doesn't evaluate or does evaluate.
it does not.
Okay, well, so that's another good precedent.
Yeah.
But I mean, I'm kind of asking, are there similar kind of constructors for ODEs that seem relevant? And I'm not aware of them, other than things for, doing systems engineering.
No, I mean, they're not just systems engineering, they're just modeling of complex systems.
Yeah, I understand. But okay, the thing I'm asking is, okay, fine. And maybe that's all we have in the PDE case is things that are specific to particular kinds of physical systems, like fluid flow, for example.
Yeah,
Never
I
mind.
Yeah.
mean, yeah. I mean, we're building a modeling language that allows for, the different domains. We're building a language that's rich enough for the different domains, but it also allows you to combine domains. These things are combinable.
Yeah, I know, which
Okay.
is great. But I think
Yeah.
it's great to have them combinable as fluid flow component, heat transfer component, and so on. That makes it
I
very
I do too.
readable.
I do too. I think that's
Okay.
much better.
Okay. All right. Onward. Okay. Solid mechanics.
Yeah. So there we've documented different stress output measures. So customers requested that you be able to specify different output stress measures.
What does that
So
even mean? I mean,
so typically in for a linear elastic stress computation, you get a Cauchy stress, but there are other stress measures, and we've added first Piola-Kirchhoff, second Piola-Kirchhoff, and Kirchhoff stress
okay. So hold on,
measures.
hold on. This my basic solid mechanics moment. Okay. Stress is a measure of force. Strain is a measure of deformation.
Yeah,
What is this? What is an output? An output stress means the force that is when you solve the equations. This is the force in the material, and there's usually a stress tensor, some rank
correct.
two
Yes.
tensor.
Yeah.
So
Yes.
what are these?
And
Are
there's
these
different measures for that. So stress is not uniformly defined. You can define that in different ways. And we've allowed customers to extract different forms of this stress. They can all be converted into one another, but you can now directly access them through this parameter
but so are
specification.
these different projections of the stress
Yes,
tensor?
yes.
Okay.
basically, yes. Yeah.
And can we get out the whole stress tensor?
Yes, the default stress tensor is the Cauchy stress tensor. They're equivalent. So if you
Okay,
have
so these
one,
are
you can
coordinate transformations on the stress tensor, is that right? Or something?
um yeah, probably you could view it like that. Yes.
Okay. What is in
It's
general? Well, okay, fine. I mean, it seems sensible to have such a thing.
yeah.
Um, there's presumably some scalar, they're presumably like principal components of the stress tensor or something.
Yeah, those are the diagonal components. So what you always get is symmetric or a symmetrized array. And if you want the principal components, you get them from the diagonal there.
So like the Poisson ratio or whatever of the, orthogonal to longitudinal deformation. How do you get that?
The Poisson ratio is well, you don't want to extract that from the stress.
No, it's from the
That's
strain.
something. Yeah. So
How do you
what?
get the strain?
Yeah, I mean, so there is the solid mechanics strain function that computes that.
What's it
So
called?
the function under the NDSolve call, solid mechanics strain.
I mean, under.
So
Oh, okay, okay,
yeah,
fine.
before you compute the stress, you have to compute the strain.
I
And
don't know why. Yeah, okay.
I mean, what we're talking about here is just stress measures, not really anything about the strain.
Okay, but if I take the stress out, if I generate the output as a stress,
Yeah.
how do I get the strain? Do you see what I'm saying? So here I've got
Mm.
this. I don't know why why is it that red error condition for the icon for the
So every component is specified.
so why is it a big red thing?
I don't know. That's a
It
different
looks like a
question, I guess.
bug to me. That looks like some kind of thing where it's expecting numbers for the symmetrized array, and those are symbolic things, and we're just showing that as an error condition, which doesn't seem right to me.
That may be something we can suggest to the people developing symmetrized array.
Roger, do you have a comment on what, or Devendra, do you have a comment on what I just said?
Yeah, yeah, yes. I think just let Itai look at it, and I can just let him know this afternoon.
I think
Okay,
you're right, Stephen. That's probably one of the assumptions there or something.
right.
Yeah.
Okay, so now how do I get the strain out of this? How do I get the strain? There's a strain tensor, right? I
Yes,
think.
that's a strain tensor, and you
No, this is
extract
a
the
stress tensor. This
so
is a stress
above.
tensor.
If
Okay.
you evaluate the function, the strain, if you remove the
Okay.
semicolon, you also get like the strain.
Brilliant. Okay,
Yeah,
fine.
there it
So
is.
if I were to take these things, so wait a minute. So this symmetrized array is a function. Is that correct?
Yes.
Mm,
No, so it's got interpolating functions
It's a
inside.
matrix field, if you like, or a
yeah,
tensor
it's a,
field.
it's a
So in other words, if
tensor
I
of
take this,
functions.
if I say this sub um the uh that thing sub um what am I doing? I'm taking that
Take
sub
into
one,
one
two.
component or
Yeah,
something.
there
Okay.
you have it.
Okay.
You can plot
It's a
that.
little weird that those variables are okay, so then I can say plot 3D of that. Oops. That no, that's of x and y, x01, y01. Cool.
I mean, here's a question for you. It's a bit tangential. What would you think about having plot 3D just getting an interpolating function and do the right thing?
I think it's a good idea.
Good. Because we have the variables. We don't need variable names. We have
Yeah, I like it. I think
The
it's a good
domain,
thing
yeah,
to do.
yeah.
like a pure function kind of thing.
Yes. Just plug the
Yeah, I
No,
interpolating
mean,
for pure
function.
functions, we don't have the domain.
right.
Well, I mean, what I mean that you don't need the variables. You have or have the
For a
domain.
black box functions, we don't have the domain. I think it's only interpolating function we
Yeah.
have
Yeah.
the
So it's very
domain.
special to that particular case, but it's an important case, I guess, that comes all the time. So yeah.
And it has an additional advantage because if we just use the interpolating function, we get the mesh from the interpolating function and we use exactly the same mesh and don't have to recompute the mesh and stuff that might be even different.
I know, but I
It's
think
got
we need to tread carefully here. Okay. So it's interpolating functions so special that integrate also need to do that now and integrate and a bunch of other functions.
Yeah.
And that is problematic.
No, except that I mean, it'll have some cost because the fact is that plot 3D expects more than one argument, for example.
Yeah.
And if I were to end it there, well, actually, I'm really surprised that it doesn't. Oh, it does do that, right? So it would take some fancy footwork there to deal with the fact that it's not that generally it expects more than one argument.
Yeah. Yeah.
Yeah, sure. That's true.
I mean, it's possible that we could make a compromise that says, you know, you give the interpolating function and the other arguments can be automatic, for example. I'm not sure.
Hmm.
It takes some design thought. But I like the idea in general of just saying, just plot it.
Yeah.
Given that we do know, you know, we do have the
We have everything we want.
Yeah.
yeah. Okay.
So the next thing, we've added a new introductory
Example. Okay. We don't
no,
need to do it.
no,
Where are we
a
looking
little
at?
bit up. So
We're
after the
boiling an egg.
yeah. So we've added a new application example, and the purpose of that application example is to show people that never have done something like this before how to specify a model from scratch with yeah. Oh, you've got an outdated version, but that's okay. It gives you a rough idea. We're still fixing this, or it has been fixed, at least some of it. Yeah. So in
Cool. Do
various
we have the
versions,
data in material data for an egg?
no, we didn't. We have
So we
we
should
get
put
to
it
that
there.
at some point. We extracted the data from some papers.
So we'll put it there, right?
I can
In the
ask people to
material
do
data.
that.
Yeah,
Yeah.
I mean that's obviously we should put it there. Given that
Yeah.
we have it, we should put it there. Is it a spherical egg?
We'll get to the proper
You
form
begin there.
and further down. Yeah, we'll get to the proper egg form.
That's the point, to get it step by step, like in six
Yeah.
steps and that sort.
Okay, that's cool.
And this is a very nice piece. Came from Wolfram Alpha, the motivation from, yeah, the idea.
And the last thing we did there is, have you ever heard of periodically cooked eggs? So basically,
I'm
you
not an expert on cooking anything, but
yeah.
yeah,
So you take an egg, you put it into boiling water for 2 minutes, then you put it into 30 degrees water for 2 minutes, and you repeat that for 30 minutes altogether. And that gives a very special form of egg. So this is a recent paper that came out in Nature,
okay.
and that's
Did
the
you
last
eat
thing that we
one?
did.
Did you try it and eat it?
Not yet. I'm waiting for my thermometer for cooking, but I'll add a picture when I have done it.
The, okay.
And so getting back to this, is the purpose is that we want to use this for blog post and teaching how to do modeling in steps.
Right, looks nice. Question. I mean, I assume that the picking this up in the RAG for the notebook assistant has happened, or
I
what's the
don't
status?
know yet.
Oh, for goodness sake. I have raised this twice before. Are you aware of this issue, Oliver?
No.
That's not good. Okay. So maybe
But I'll look after it. Yeah, I'll look into it.
is Natalia taking notes here and things?
Yes, I am.
Okay, so I think that goes to, gosh, who is dealing with the who is PMing the RAG process?
Felipe.
Okay, Felipe, fine. So Natalia, please make sure again that this is communicated. I think there was some issue with these, and there's certainly there's some issue about the format of these things that needs to get resolved.
Okay.
Now what's happened to the business about turning these into packlets and not having
so we get to that in a second. There is one function where we have, so function interpolation is the first function that absorbed a FEM function that we can look at.
Okay. Shall I look at it here? Or
the ref page. You want to look at the ref page. So there, what I've done is I've added function interpolation over regions. So you specify an expression, an XY over the omega, and then it does construct the interpolating function over that region.
So
And that's based on
remind
flat.
me,
Yeah.
constructs. What's the
So,
difference between interpolation and this?
so
Interpolation is for data only. This is
Oh, I
functions.
see, I see.
Yeah.
Right. Okay, I remember this. Yes.
right.
And what this does in, in low dimensions, it will sample it and will get, do simplicial.
Right. Yeah, I remember this. This is
Okay.
an old function, but yes.
Very old function, yes. So I've extended that to be able to,
I think that sounds very good. I mean,
yeah.
you should put the region version, shouldn't you, in the top usage messages? I don't know
Yeah.
how we do that for other functions.
Oh no, it's going there.
Okay.
This is just tentative right now.
Oh, I see, I see. That's yes,
Yeah,
right.
yeah,
This is in the
yeah.
right place.
I
Yeah,
haven't made it live
that's
yet.
great. So I mean, this is the way it should be. Was it in some other weird context before or something?
Yeah, so it was evaluate on element mesh is put into that function now. That was in the FEM context, yeah.
I see.
And for
Great.
future, so this is the first one that's being absorbed, and I have suggestions, but those are only for the version after this one.
Yes.
So we need a bit more time to do that.
Okay, all right,
But
fine.
we're working on it step by step, but we're making progress.
That's good because that's really adding a lot of value to make it in that
Good.
form.
Yeah. So this function is a new proposed extension to interpolating functions.
Yeah.
Where you can specify how extrapolation is happening, whether it's happening at all, whether it should give a message, how it should extrapolate, stuff like that.
Okay, so it shouldn't be called if it's a thing where it can give a message, it should be called extrapolation action.
Action. I see.
Action, okay, yeah.
I think so. I mean, if what no, come on. Bool, what the hell is that? What are we doing here? We writing C code? What are we doing here? What is that?
Use function extrapolation.
I have no idea.
That's the type of that. I don't know what that is. That's wrong there.
But anyway, so
that's not right.
But this is a kind of cruddy format, syntax, right? So let's just understand what this should be.
Mm-hmm.
So is this okay? You've got an interpolating function,
mm-hmm.
and then you give a value outside the range.
Yep.
And the question is, what should happen?
Correct. So right now,
yeah, go ahead.
Right now, it extrapolates and it gives a message.
Well, so if
you can copy an example from below and remove the extrapolation handler, then you don't have to type so much.
Well, okay, but so this. I don't think this is quite right. It's design. Okay, so the default behavior is message. Oh, but it then does the
it
produces
extrapolates. It does do something. It extrapolates. But you don't necessarily want that. So sometimes you do, sometimes not.
See, what's really weird, we've got an interpolating function.
And it does actually extrapolate by default.
No, I understand. I understand. But the name extrapolation function is really weird because we might also have a thing called extrapolation, which is kind of like interpolation. I mean, why do we not right now have a function called extrapolation? Because basically that operation is done by interpolation. Is that correct?
Yeah. That's yeah. Well, at least that's my understanding. Yeah.
I mean, one could imagine, and this has come up, like if you want sort of an infinite domain, that you have a certain tail behavior of these things.
Yes.
I don't think we have a super good use case to think of right now, but that's come up.
Well, I mean, there's a lot of cases where I would say outside of the range, make it 0. Outside the range, make it infinity.
Yeah.
Those are
Those are two examples.
That's exactly what this one does, yes. So
But you
Right.
could also have something else. It's going to fall off at a certain exponential rate or something.
right. But so this would be, I mean, this is an out of range. I mean, one thing is the out of range function somehow that
Yeah.
is
And so,
either,
for instance, you could define like an interpolating function on a, on an infinite domain if you had such a model.
well, wait a second. I mean, that you could say that you get interpolation within a certain region, and then outside of that region, it does whatever you want specified, whatever you symbolically specified for it to do. Is that what you
Right.
mean?
And that
Yeah.
could be going
Yes.
back to the previous part of the region, so that you have practically an infinite region.
What do you mean going back to the? You mean
So I
a
mean, if
periodic
you
system?
use mod or something like that.
But that's different because there's domain and range here. We got to decide what we're talking about. I mean, so one thing
Oh,
is
yeah.
the output value. You could either specify the output value. Okay, what can you do? You can specify the output value. You can specify the input value for a given, the input value to feed back into the interpolating function, right? Or you can specify a message or something. Those are the things you can do.
I'm not quite sure about what the second one is. I
Well,
don't
that's what
understand
you
that.
said. If you want it to behave periodically,
Right, got it. Yeah. Yeah. But 1 and 2, I think, are
no, they're not the same. You can't have them be the same because they're different, right? One of them, I mean, unless for this one you want to repeat the interpolating function and just
yes.
say, which is pretty weird. I mean, then why aren't you doing that? You know, that's just a weird thing to do. That you're saying interpolation and interpolating function, then it's the same interpolating function with a different
If you
argument.
have
Why aren't you?
something with periodic boundary conditions, you might want to do that.
No, I understand that, but why isn't the whole thing just, well, but because this is a way, an El Cheapo way to insert a mod so that you can still have the top level head be interpolating function. Is that the point?
I mean, the point is to create a function that is
I know, but
infinite.
you can always do that by saying interpolation, this interpolating function,
Mhm.
compose that with, whatever it is at star, compose that with
Yeah,
mod,
sure.
whatever
Okay.
it is.
Yes, there is other ways to do that. True.
Yeah, but
Absolutely.
and having
Yeah.
something where you repeat the interpolating function,
Yeah.
where you say this and you repeat the interpolating function is pretty weird. You say extrapolation function, arrow, and then you repeat the interpolating function with the mod.
No. Yeah. I mean, there's an example
Yes.
in the documentation below.
That's
If
the
you
only thing
think
you
it's
can do.
weird, that's fine. Okay. I
I mean, this is
don't
weird,
think it's
right? It's that.
no. There's no interpolating function. It's just the mod that you need.
That's not correct. Think about it. It's not correct. You're either specifying the output value or you're specifying the input value. You can't have it both ways. You're either saying the result should always be zero, boom. You're not specifying
But
that's
it
zero.
could be a function. It could be a function of
I
x.
understand, but the function you're specifying, if it's going to be periodic, the function you specify has to contain the interpolating function, right?
Sorry, I can't follow you. No.
Let's
Roger,
look at
explain it.
yeah,
Maybe
yeah.
I just don't get it. I don't
No,
get
I
it.
agree
No.
with you, Stephen. But let's look at your example, Oliver, because I don't think I
Yeah.
follow you. So let's see what you did.
So let me see where it is.
All of these are just returning the output value of zero, for example, right?
Yes.
Okay.
Yes.
So, okay, this one here.
There it is. Yeah.
Right. But that's doing what I just did, right? It's putting the interpolating function back in there.
Right.
Okay.
Right? The temperature is the interpolating function.
I see what you, okay. I got it. Yeah.
Which is kind of screwy, right?
Yes. Okay.
So these are the three cases.
So
right?
the first one is the important one. I don't care so much about the infinite domain. I just wanted to support that Roger said that this is in principle possible.
This will support an infinite domain. It just doesn't. This thing here, where you feed it back into the same interpolating function, you're doing that by hand, basically.
Yeah. But the item I care most about is the first item then.
Okay.
I mean, that's basically what we've done in all other examples. This was
Right.
just
So I don't
like an add-on.
understand why. Okay. To me,
But this would be useful to have a few string names of common behaviors, I think.
that's
Because
fine.
they would be easy to, those would be particularly easy to specify.
Yeah. Just say periodic or something.
And then
So
the general function case can be there too, which is for everything, so to speak, everything else.
it bothers me. We can't call it extrapolation function because it's too close to interpolating function.
Hmm.
Do we have any other cases where we're specifying sort of out of range behavior?
Well, I mean, time series had a
Yeah,
missing handler, but
But
That's
it's
different. That's missing in
yeah.
the range, right?
yeah, I mean, and yeah.
asymptotic, we
What's
got
it?
something like where you might want more terms, but I mean, what's that? The series term goal kind of thing, like a goal, but that's
So
No, that's
different.
different.
what's wrong with
Yeah.
extrapolation action that you suggested?
Yeah, I think that's what he says it early
It's
on.
wrong. It's wrong. It's not what we want because the fact is the action, whether you give a message or not, first of all, you can always specify the message. If it's a function, you can always specify the message by just doing this, right? And putting a message in there.
Hmm.
And second of all, I think it would be useful to if there is a value, you don't really want a message, typically,
Yeah.
right? If you specified a value, you don't want a message.
Yeah.
So, if you say extrapolation function arrow none, then it's going to say, sorry, I can't do it. It's a message, it returns unevaluated or whatever.
Yeah.
And the automatic case could be a message and, extrapolation. Okay, so the only case that we're not covering there is extrapolation without a message, right? In
Yeah.
other words, you want default extrapolation but without a message. And um, well, it really is naturally called extrapolation function. But I really hate that, given that interpolating function is a function.
Strategy, method, would any of those work? I mean, because they kind
No,
of
because
mostly
it's a value. It's a value.
yeah. I'm just saying them what people might understand as being what it's purpose. The extrapolation method would very clearly say how
Well,
you want to.
extrapolation value would be, but it's a function. That's the problem.
Yeah.
It's a function. I mean, is there some generalization of out of range functions?
I
Like I
don't
think we
think we'll
might
ever
use.
have an extrapolation function. I mean, that doesn't make a lot of sense.
Yeah,
I mean,
machine learning mostly. Like I mean, it's too speculative to on its own.
approximation
How, and
functions,
if we
yeah.
just, I mean, well, no, just extrapolation and then you specify the
No
function.
way. That will be even worse, right? Because
Yeah. It's
interpolation and extrapolation would be. But listen, I think we should have a name that we could use elsewhere that says what to do if you're out of range. Because I think that would be a useful thing. I think we should look at other functions that can use that.
Mm.
And what about out of range function?
Well, I think something like that that was what I had here.
Yeah, there. Yeah, right. Yeah.
Is it the right thing? I always forget range and name.
Domain, right? Function
Is
domain.
is it this is the domain of the function?
Yeah.
Why am I'm just irreducibly confused.
Yeah,
Kalayana,
we have a
Boskin was
function domain,
suggesting, what
function.
about an inversion function? Also probably has this issue, yes, of having an out of, sorry, say what you're saying, what?
There's a function property called function domain. It will give
Indeed,
you the function domain of because we
right.
don't store, the math tradition is to not, record the domains.
Yes, I get it. Is there a more elegant way of saying, it's going to say something totally stupid.
Well, I'm curious.
To apply. That's really badly phrased. I mean,
It might just say extrapolation handler. I don't know why, but we'll see.
oh, for goodness sake. There's some problem which, that's really weird. Weird. Well, can somebody report that, please, right away? I don't know. I assume that's just a problem for me, not for other people. Could you, Natalia or Yazbal, could you report that?
Yes.
That's really a bad thing. What the hell is that? Okay, I think this kind of needs to be. Well, so much for that. That was not what I was expecting. Okay. That's a shame. I was hoping to consult it. Okay.
Extrapolated values, would that work or would that not work?
No, there's got to be a function.
Or has to have a because the function specifying it. Yeah.
I mean, with sort of extrapolated value function.
Yes, I think that might, it's a bit long, but I think some of that looks like you could use the, don't have to use the abstract noun.
Let's start with extrapolated value function. I don't know. I prefer something about out of domain, but we need some way of saying, we need a better way to say out of domain function, because I think we can use that in other places. And why don't you guys look for other places we might use it? Does that make sense?
Yep.
And then bring that back.
Okay.
And then what I would suggest, the default values, the automatic does the present behavior message plus extrapolation. None would just return unevaluated. And then otherwise it's a function. Now, yeah, that's what I would suggest. Okay, onward.
Right, so I've rewritten the PDE parser that's merged, but it's
Good.
not switched on by default yet. Hopefully in the next version, there's still one issue that I need to resolve. I didn't finish that yet. So
neural net PDE, what's
yeah, that's an experimental stage. And I think we came to the conclusion that so we have a function now that we're going to put in the function repository together with Jason Biggs. You suggested that we meet. We did, and we tried to combine efforts there and make a combined repository where we have these chemistry, quantum chemistry functions that we have. Right. Fem core error page got updated, and there's going to be an update for 14.3 as well, of course. So Alessandro wrote a blog post. Unfortunately, that was denied. They didn't want that. And we're still having an X post, Martin, that's in progress. I don't know if there's a new status on that yet, but that's in the works. Books and courses are set for 2026. We'll see how far we get with those. And we started to organize another PDE modeling conference specifically, like we had one last year, and we're going to have another one this year.
Cool. Okay.
Yeah. So like a topic conference. And those are a few presentations where we were active.
So
that's
these books, are they these are in Okay, so first of all, we're really getting to the point where there are no sort of custom contexts and things, right?
We're working on that. We're not there yet. That's going to
Okay,
take a
fine.
few versions to get there, but
Yeah.
we're working on that.
Okay. And with respect to the books, are they getting published through Wolfram Media, or how's that
Yes.
working?
Yes.
The same
Okay.
idea that a course with Wolfram U and books with Wolfram Media, the same pattern as everything else. So I'll guide
Cool.
about that.
Okay.
Yeah. That looks
Good
like the
stuff.
best thing to do.
Looks nice, guys. Anything else we should cover in this meeting?
No, I think we're good.
Very nice.
One other update maybe because we discussed in the GPL meeting. I'm about halfway through for trying to compare what we have to other people's stuff. So we
Okay.
we can
Good.
have a meeting about that sometime soon.
Sounds good.
Yeah.
Okay. Nice to chat with you guys, and I think we have another live stream coming up at more or less the top of the hour. So see you all. Well, see some of you there.
Thank you. Bye
Thanks,
now.